Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain Unit 4, Measures of Dispersion. Under the topic is Skewness, coefficient of skewness, how to find. In this place, what is meant by skewness? Here skewness means asymmetrical distribution is called as skewness. Symmetrical distribution is called as normal distribution. Here asymmetrical distribution. We'll see lack of symmetry. We can say in simple way. Then we can say it is called as skewness. We'll see here skewness definition. What are the formulas we are going to be used? What are the different types of skewness is there? Then we'll solve all the three different types of series of observation. Now we are going to study about skewness. Skewness means lack of symmetry. We study skewness to have an idea about the shape of the curve which we can draw with the help of the given data. Any data, if it is given, that data should get a symmetric. If it is not getting a symmetric, then we cannot able to study about that in the normal distribution method. So that we are going to apply your skewness. When you will say the skewness will happen, when you will not say skewness will not be happening. If in a distribution mean, median, mode values are equal, then we can say symmetric distribution. It's called normal distribution, symmetrical distribution. Suppose if it is not equal, then we will talk about skewness. What are that? We are going to see now. In a distribution, mean greater than median or greater than mode, or we can say mean less than median, less than mode. In that will it come. Always median value will be lies between mean and mode. Then it is not a symmetrical distribution. Then we will call it as skewed distribution. In such a distribution could be either be the positive direction or negative direction. Then we can say it is called as positively skewed or negatively skewed. Symmetrical distributions. In this format, it is a bell-shaped format. In any direction, if you cut or you can make equal two parts, then it is called a symmetric distribution. In this case, mean equal to median equal to mode. It is clearly from the above figure symmetrical distribution. The values of mean, median and mode coincide. The spread of the frequency is the same on both the sides from the center point of the curve. Positively skewed. When it is not there in equally, that is mean, median, mode values are not equally, then we can say skewed distribution. In that we can say there are two varieties of skewed distribution is there. One is positively, another one is negatively. Now we are going to study about positively skewed distribution. This is the one. Right side will be extended. Left side will be normally it is there. Right side will be extended. Its values are lies in the particular place. In this place, mean greater than the median, median greater than the mode. Here we can say positive side is being skewed. That means it is not in the proper way, not proper bell-shaped. The value of the mean is maximum and that mode will be least. Median will be, always we know that median will be lies between mean and the mode. In the positively skewed distribution, the frequencies are spread out of the greater range of values on the right hand side than they are on the left hand side. Negatively skewed distribution. It's a negative. Left side will be skew. That means it's not in the proper bell-shaped curve. It's clear from the board diagram. The negatively skewed distribution, the value of mode is maximum. So mean less than the median, less than the mode. So median value in between mean and mode. Here mode value is greater than the mean. Then we can say it is called as negatively skewed. In these distributions, frequencies are spread over the greater range of values on the left hand side than they are on the right hand side. That is called as negatively skewed distribution. Now we are going to study measures of skewness. What are the measures of skewness is there? There are three types of measures of skewness is there. That is the one is Pearson coefficient of skewness. The second one is Bowley's coefficient of skewness. The third one is measures of skewness based on moments. We are going to study Pearson coefficient of skewness. So here you can say skewness equal to mean minus mode, absolute measure of mean minus mode we can find out according to Pearson. This measure is not suitable for making valid comparison of the skewness in two or more distribution because unit measurement may be different in different series. Then this is a formulas will be used. Why this difficult to use relative measures of skewness? One is coefficient of skewness equal to mean minus mode divided by standard deviation. In case of mode is ill-defined, the coefficient can be determined by the formula 3 times of mean minus median divided by standard deviation. These are two ways we are going to resolve the coefficient of skewness problem. We'll take individual series of observation. The first problem, here we need to remember that all the three types of series observations will be, first we are going to solve mean, then standard deviation, then mode, then coefficient of skewness. Suppose mode is ill-defined, then we are going to solve as using the median. The formula will be used. Again, I'll repeat it. Mean, we are going to find out first what we studied in the third unit and fourth unit. Then standard deviation, then mode. Suppose mode is ill-defined, then we will study median. Same procedure will be followed. Again, we are going to learn here. The given series is individual series of observation. We know first we are going to be find out standard deviation. First we will be written in the vertical column. Then we know first we need to find out mean. Mean equal to summation x divided by n. Sum of all the x values. 4 plus 9 plus 11 plus 12 plus 17, 5, 8, 12, 14 added, we will get 92. So 92 divided by number of values 9. So we will get it as 10.22. Here we can take approximately and 0 decimal point concept. We will use mean equal to 10. This value we are going to be solve the deviations. Deviation is equal to x minus x bar. Here x bar is 10. So 4 minus 10 minus 6, 9 minus 10 minus 1, 11 minus 10 1, 12 minus 10 2, 17 minus 10 7, 5 minus 10 5, 8 minus 10 2, 12 minus 10 2, 14 minus 10 4. So then we are going to find out at the squares of this value. What is the values? T square, 6 square 36, 1 square 1, 1 square 1, 2 square 4, 7 square 49, 5 square 25, minus 2 square 4, 2 square 4, 4 square 16. Here negative values also. When you are getting a square, then we get positive value. Sum of all the d square values column, 36 plus 1 plus 1 plus 4 plus 49 plus 25 plus 4 plus 4 plus 16 equal to 140. Summation d square equal to 140. This is the values we are getting as summation d square. Now we are going to find out standard deviation. Standard deviation formula is square root of summation d square divided by n. Summation d square value 140. 140 divided by 9. So we'll get the value 15.555. Square root of 15 is 3.9439. This is the values of standard deviation. This also already studied. Again we are going to recalling. Once we find standard deviation, then we can go for next one. Here mode equal to 12 because 12 is the number maximum time repeated comparatively other numbers. So mode also we got it. Now we are going to use coefficient of skewness. Coefficient of skewness formula is mean minus mode divided by standard deviation. So mean value 10.222 minus 12 divided by 3.9437. Mean value, mode value, standard deviation value we are substituted. Then simplify. 10.222 minus 12 will get minus 1.7778 divided by 3.9439. So this value will get negatively 0.45077. Whatever get 0 gets, there is no skewness. Minus you get, it is negatively skewed. Plus will get, it is positively skewed. So coefficient of skewness equal to minus 0.4507 will get. Then coefficient of skewness is negatively skewed. This is the way we need to find out individual series of observation problem how to find coefficient of skewness. Now we are going to study coefficient of skewness for discrete series of observation. Just also same procedure we are going to follow. What we learned the previous series of observations. First we need to find out mean, then standard deviation, then mode. If it is not, then we can find out median. Then use the coefficient of skewness formula and then substitute. Now we are given the values. Then we are going to write on in the vertical column. First mean we are going to find out. Here we know x and f is there. First we need to be multiplied with the f and x. Formula of mean equal to summation fx divided by n. Then we will be used. So f and x multiplication 7 into 30 210, 10 into 40 400, 14 into 50 700, 35 into 60 2100, 102 into 70 7140, 136 into 80 10,880, 43 into 90 3870, 8 into 100 800. Total of f and x column 210 plus 400 plus 700 plus 2100 plus 7140 plus 10,880 plus 3870 plus 800. The total value is 26,100. Then we can substitute 26,100 divided by sum of frequency values 355. So divide it. Then we'll get 73.521. So approximately will be considered as 74 for the basis of 0 decimal point. Now we need to take mean is 74, that is x bar. Now we need to find out mean. Based on the mean we need to find out deviation. Standard deviation we are going to find out. D equal to x minus x bar. Here x bar we will consider as 74. So we will find out 30 minus 74 minus 44. 40 minus 74 minus 34. 50 minus 74 minus 24. 60 minus 74 minus 14. 70 minus 74 minus 4. 80 minus 74 6. 90 minus 74 16. 100 minus 74 26. This deviation squaring value is, we are going to find out in the next column, d square. 44 square 1936, 34 square 1156, 24 square 576, 14 square 196, 4 square 16, 6 square 36, 16 square 256, 26 square 676. So in this way we need to find out here frequency is given. So we'll find out another column. What is that? F into d square. So we'll use it. 7 into 1936, 13,552. Then 10 into 1156, 11,560. Then 14 into 576, 8064. 35 into 196, 6860. 102 into 16, 1632. 43 into 256 will get 11,008. 8 into 676 will get 5,408. Total of f d square value, that is 13,552 plus 11,560 plus 8,064 plus 6,860 plus 1,632 plus 4,896 plus 11,008 plus 5,408. Altogether, if we totaled, we'll get 62,980. Then we can apply standard deviation formula. Standard deviation formula is square root of summation of d square divided by n. Substitute the value, square root of 62,980 divided by 355. Divided square root of 177.408. Take square root of that, 13.3194. This is a standard deviation. Now come to, we need to find out mode. Mode here, this problem is, so frequency maximum here is 136. For that, x value will get 80. So here mode equal to 80 because of maximum frequency is 136. So we'll get mode equal to 80. Now if know mean, mode and then standard deviation. Use that formula. Coefficient of skewness equal to mean minus mode divided by standard deviation. Then 73.521 minus 80 divided by 13.3194. Simplify that. Minus 6.479 divided by 13.3194. Then we'll get minus 0.486433. Here we'll getting the negative values, so the given distribution is negatively skewed. Negatively skewed. So this is a problem of finding the discrete series of observation. Next we are going to solve the continuous series of observation. We need to remember that continuous series of observation, whenever we are solving whatever we studied in the third unit, all conversion of exclusive class intervals type. So we need to remember any things applicable, we need to be follow. In this problem, more than is given. So we need to find out first class intervals, exclusive class interval. So we need to consider here, see 10, 10, 10 is the difference is there. So we'll find out 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. It is in the decreasing frequency. So we need to subtract second value minus first value, third value minus second value, likewise continuation. Here you see 100 minus 97, 3. Difference between the two continuous frequencies. 97 minus 90, 7. 90 minus 70, 20. 70 minus 40, 30. 40 minus 25, 15. 25 minus 15, 10. 8 15 minus 8, 7, 8 minus 3, 5. Last one, 3. Then we can write in the class interval and frequency form. We can solve by normal continuous type problem. So this is the way we'll get it here. The problem. This problem we need to find out first mean, standard deviation, mode. If mode is not possible, then median. Then we can apply coefficient of skewness formula. This problem will be written in the vertical type. We know the mean formula summation fx divided by n. Maybe here is the no place in this slide. Then we will go for the next slide. I will explaining what is that value got it. Now midpoint we need to find out because of your class intervals is getting 10 plus 20 divided by 2, 15. So 20 and 30 midpoint 25, 30 and 40, 35, 45, 55, 65, 75, 85, 95. This is a midpoint. I will get lower limit plus upper limit of the class interval divided by 2. We will get it as midpoint value. Then f and x multiplication. 3 into 15, 45, 7 into 25, 175, 20 into 35, 700, 30 into 45, 1350, 15 into 55, 825, 10 into 65, 650, 7 into 75, 525, 5 into 85, 425, 3 into 95, 285. Total of frequency is 100. Total of summation fx equal to 4980. This is the value we are getting. Total of f and x value column. Now we know we will find out. So total of fx divided by n. So we'll get 49.8 will be considered as 50. Then deviation can be solved. Here deviations we need to be find. Deviations equal to dx minus x bar. X bar how will you find? Summation fx divided by n. Summation of x is 49,980 divided by 100. So we'll get 49.8. Then 0 decimal point will get 50. So that 50 mean will be considered and finding deviation. D equal to 50 minus 50 minus 35, 25 minus 50 minus 25, 35 minus 50 equal to minus 15, 45 minus 50 equal to minus 5, 55 minus 50, 5, 65 minus 50, 15, 75 minus 50, 25, 85 minus 50, 35, 95 minus 50, 45. Then we need to find out square, d square value. 35 square 1225, 25 square 625, 15 square 225, 5 square 25, 5 square 25, 15 square 225, 25 square 625, 35 square 1225, 45 square 2025. Then multiply with the f into d square will get this column. 3 into 1225, 63675, 7 into 625, 4375, 20 into 225, 4500, 30 into 25, 750, 15 into 25, 375, 10 into 225 will get 2250, 7 into 625, 4375, 5 into 1225, 6125, 3 into 2025 you get 6075. So total of FD square value is, that is 3675 plus 4375 plus 4500 plus 750 plus 375 plus 2250 plus 4375 plus 6125 plus 6075. You will get 32,500. Previous slide we don't have place, so I explain mean here again. So 4980 divided by 100, so we'll get 49.8. As per the calculation convenience will be taken as 50, 0 decimal point approximately. Now mean deviation we are going to be find out. Summation FD square divided by n. So 32,500 divided by 100, the value is, we'll get 325. Square root of 325 is 18.0277. So this is the standard deviation value. Now we are going to find out mode. This is the class interval and frequency. In that frequency, maximum value is 30. So we will be considered as F1. Previous value is F0. Next value of frequency is F2. So maximum frequency F1 for that class interval is 40 to 50. So we'll get model class equal to 40 to 50 maximum frequency. Then mode equal to L plus F1 minus F0 divided by twice of F1 minus F0 minus F2 into I will be considered. Then L value, lower limit of the model class. F1 value, maximum frequency of the model class. F0, previous frequency of the model class. F2, succeeding frequency of the model class. Here F1 is 30, F0 is 20, F2 is 15, I equal to 10. Then we'll get 40 plus 30 minus 20 divided by twice of 30 minus 20 minus 15 into 10. So 40 will be as it is written, 30 minus 20, 10, 2 into 30, 60, minus 20, minus 15. So we'll get the value of 40 plus 10 by 25 into 10. So 10 by 25 will get 0.4 into 10. We get 40 plus 4, 44. So we'll get coefficient of skewness equal to mean minus mode divided by standard deviation. We know values mean, mode and standard deviation. We can substitute 49.8 minus 44 divided by 18.027. Substitute the values and then 5.8 divided by 18.027 will get, then we'll get 0.32173. This is positive value. The given distribution is positively skewed. This is the way we can able to find out continuous class interval type. Here ends our syllabus of measures of dispersion completely over. Still more any clarification you can call me and can ask any doubts. Thank you for watching. All the best for your future. Thank you. All the best.